Chemistry, this lesson is on the concept of mass percent and how it can be applied to empirical formula problems. Okay, so let's say that I asked you to go down to the ocean. I want you to analyze seawater. And let's say I tell you that I know that seawater is 30% NaCl, salt, and the rest water, 70% water. But you can't use percentages in a chemical equation or in chemical calculation. You need to convert to grams or moles. So what you can do is, if you know that it's 30% salt and 70% water, then you simply take a 100-gram sample. Why 100? Because it's a nice round number. And if you do that, that means you'll end up with 30 grams of salt and 70 grams of water. So you converted those percentages into something useful, which was grams. Okay, so sometimes you're given the element in percent rather than grams or moles. Since you have not been given a quantity of the sample in grams, you will choose 100 grams. That's just it. You're going to choose 100 grams always. By doing this, each of the percentages can be converted to grams. So, example, what is the empirical formula of a compound that is 43.6% phosphorus and 56.4% oxygen? So if we choose a 100-gram sample, this will yield 43.6 grams of phosphorus and 56.4 grams of oxygen. Now we have units that we can use in chemical calculations, that is grams. So compute the number of moles. So there's the grams of phosphorus. You take the molar mass, 30.97, and you come up with 1.408 moles. For oxygen, 56.4, take the molar mass of 16. This is an oxygen atom, so it's 16, and you get 3.525 moles. So now we do what we did in empirical formulas before. We simply create a ratio with the smallest number on bottom. So the smaller of the two numbers is always going to come out to be a ratio of 1. And the larger of the two in this case is 3.535 over 1.408. That gives you 2.5. So those would be your subscripts, but since 2.5 is not a whole number, you're going to multiply it by 2. And you're going to multiply the 1 by 2. You have to multiply both of them by the same factor. And you end up with phosphorus at 2 and oxygen at 5. And so this produces the empirical formula of P2O5. So we'll do a quick assignment to practice this concept. All right, so that takes care of this lesson, and we're going to have one more lesson on the concept of empirical formulas.